morning, everyone. How did your homework go? Any questions? Okay. Right, if you don't have any questions, today we start section 3.8. Implicit differentiation. Okay. So before we start, let me tell you a little bit about an equation versus a function. So suppose I tell you, let's consider the following equation. Y equal x squared. Okay. And so what's an equation? An equation is basically an equality between two expressions. Y equal x squared is an equality between two expressions. And if I tell you sketch the graph of this equation, it means we have to sketch all the points xy that satisfy this equation. So if we sketch all the points that satisfy this equation, of course, we know that we get a parabola. Now, this equation, y equal x squared, does it give x? So does this equation, gives gives y as a function of x. Okay, means does this equation give us for every value of x? So can I find a function? So does does the equation gives y as a function of x? It means for every x, do I have a unique y such that the point xy is on the graph? And of course, in this particular problem, for every x, there is a unique y. So if x is 1, I have 1. If x is 2, I have 4. If I have 3, I have 9, and so on and so forth. So we say here that the equation gives y, so the equation gives y explicitly as a function of x. Explicitly, it means you give me x, I give you y. There is no, as a function of x, there is no ambiguity in the issue. Now, suppose I take the following equation. Y squared equal to x. Okay. So this equation here, this equation gives y as a function of x. It means for every value of x, suppose I take x equal to 4. This equation, how many values of y does it give me? So if I take x to be 4, okay, if x is 4, there are 2 values of y that will satisfy this equation. That is +2 and -2. So if I'm going here to sketch the graph, if x is 4, I don't only have 1 y, I have 2 of them that satisfy this equation. If I take x to be 9, I have 2 of them that satisfy this equation. If I take 1, I have 2 of them. So does this equation, so if I graph, we're going to have basically, and we'll talk about that a little bit more, we're going to have really, for every x, we have 2y. So does this equation gives y as a function of x? What will be our answer automatically? So here, y is not a function of x. Because if I give you an x, well, there are 2 y's. And the definition of a function is for every x, there should be only 1 y. Okay. Now, however, if we take this equation here, and if we try to solve for y, we're going to have y equal plus or minus the square root of x. So it means that if I'm graphing this, so I'm going to have 2 functions. So the y is the plus square root and the minus square root. The upper piece here, this is the positive root. And this down here is the negative. So that's the negative square root. Okay. So what's happening here? If I'm only interested in the positive y, so if I am right here, for example, and I tell you, okay, I'm only interested in the points which are on the upper branch. Here, y is a function of x, because if I have x, the y is the square root. So if I am only interested in the positive value of y become a function of x. And if I'm only interested in here, y is a function of x. So the y is a function of x depends on basically the range in this case. So there are two functions of x. If I am here, there is one rule. If I am here, is it one rule? So suppose now I'm asking you the following question. Find the slope of the tangent to the graph of y squared equal to x. So suppose I ask you about this question. Suppose I want this slope. I want the slope of this line. Now, I have to tell you now, I cannot tell you at x equal 1 or at x equal 4, because x equal 4, there are two y's. So I have to be very precise. I tell you at 4, I want this one, square root of 4. It means at 4, 2. So if I want the slope at this line, I have to tell you exactly which point, because I cannot tell you at x equal 4 because there are two different values. So, okay, how are we going to find the slope? All right, the way we say that, if I am up here, if I am at the upper branch, y is the square root of x. So I'd say, okay, so y prime is a half, x to the half minus 1. So at the point 4, 2, the slope is going to be 1 over 2. The square root of 4 is going to be 1 over 4. Okay? Now, suppose I ask you the same question. Now, suppose I want down the slope of the tangent at the point 4 minus the square root of 4. Now, if I want the slope here, right there, this slope, I need to use another formula, because here the y is the minus the square root. So it depends on the point on the graph. I have to use different form. So y prime is going to be, if we do the math here, it's going to be minus 1 over 4. Okay, so this is an equation. Relate x and y. This equation doesn't give me y as a function of x. It gives me actually two different functions, depend where I am on the graph. So if I want to find the slope here, I have to use one formula. If I find the y here, the slope here, I need to use a totally different formula. So I need to solve for y as a function of x. So now here's the question. Can I do this problem? Exact same problem. Find the slope without having to solve for y as a function of x, without having to know what's the formula if I am here and what's the formula I am here. So we're going to learn another process that we will call implicit differentiation that will allow us to do that. Okay, so I will not be able to, in a way, implicit differentiation, it means we were not going to be solving for y as a function of x explicitly in a clear way and do it. We're going to do it in a way that we call implicit. So let us do that. So I'm going to do the same problem, but I'm going to do it slightly different way. Okay. So the idea of implicit differentiation, a little bit confusing at the beginning, but then you'll get used to it. So the question is, again, let's consider the equation y squared equal to x. And the question is, find the derivative, dy dx. And now I'm going to be very precise at the point 4, let us say, and the square root of 4. Okay, all right. Let's see how we're going to do. So the way we're going to think about that is the following. y squared is equal to x. But y intuitively, whether I am here or here, is actually a function of x. It's a function that is changing. So it's not one function. It's a function, actually, I don't want that. Find dy dx. It's a function that is changing. If I am here, I have one function, but if I am here, it's a different function. So the way we will approach those problems is like this. In the back of my mind, I'm going to do it actually in two different ways. In the back of my mind, I say y is a function of x. If f changes, but it's still a function of x. So intuitively, in the back of my mind, I don't have y squared here, but I have actually is a certain function of x. That's really what I have. What it is, it depends, it changes, but it is at the bottom of it a function of x. So this is actually tells me that f of x squared is equal to x. Okay. So what I'm going to say is that, okay, this is a function of x, and this function of x, if they are the same, it means the derivative of x of the first expression is the derivative of x of that. So I say, okay, those are equal, they have the same derivative. Right. Now that's the hard part. What's the derivative of x? Not a big deal. What's the derivative of f of x squared? I'm asking you the question now. What's the derivative of f of x squared? Let us see something in this. What I have here actually is, if you think about it, the chain rule. What do I mean by chain rule? So I need the derivative of f of x squared. Suppose I tell you let z equal f of x squared. What is the derivative of this function? This is really a composition. My inside is f of x, and my outside, so this is the inside this time, and the outside, let me call it h of u, is u squared. That's the outside. And that's the inside. So the derivative is going to be equal to the derivative of the outside, it's 2u, but we evaluate it at the inside, times the derivative of the inside, which is f prime. So the derivative of this function by the chain rule is 2. So now I'm going to use absolutely the chain rule. It's 2 times f of x times f prime of x, which will give me, if I solve for f prime, this would give me that f prime of x is 1 over 2 times f of x. So in terms of y prime, f prime is actually the dy dx equal 1 over the f of x is actually my y, which is 1 over 2. Right? So basically, we're thinking that y is a function of x that changes. Y doesn't become, I don't understand. Y doesn't work when we do x squared become 2x. We don't have x squared. We have f of x squared. We have a function of x. So I don't have any x squared in this problem. This is here, that's a function of x. So there is no 2x. I don't know if I answered you, Elijah. I'm not sure. All right. Now I'm going to do the same problem again. But instead of putting f of x, I'm going to keep y. But here is the thing. Even if you keep y, you have to keep in your mind somewhere that y is not a y. Y is f of x, but my f is changing. But I don't want to worry about it. So the approach you're going to do is, and I'm basically going to copy, going to work like this. I say y squared is equal to x. Y is a function of x. So I'm going to differentiate, but instead of writing f, I'm going to keep this x. is equal to that. So I'm going to say this is equal to this. But remember that this is not a y. This is that. That's what I have to keep in mind. Now, the derivative of x is 1. So this line, I'm rewriting it, but instead of writing f of x, I'm going to keep y in here. Now, what's the derivative of y squared? This is not really a y. This is something that depends on x, which is square root of x in my previous problem. Or probably it could be sine of x. I don't know what it is, but it is a function of x. So it's going to be the derivative of y squared. The derivative of y squared is again the chain rule. So this is y squared. I want to find its derivative. Sorry, its derivative. Now, y squared is a function of x. That's how we have to think about it. That's really the picture. So even if I write y, but it's not really a y, it's a function of x. So its derivative, so g is, let us say, y squared. So its derivative is going to be, y is the outside, is u squared. It's the same picture, but now we're kind of abstracting it a little bit. And the inside is y. So what's going to be the derivative? The derivative of the outside is 2u, but we evaluate it at the inside, which is the 2y. But we times it with the derivative of y itself. So even if I put a y in here, I keep in my mind that y is a function of x, but this function is changing, but this still locally it is. So the derivative of y squared is going to be 2y times the derivative of y with respect to x. This is that line right here. So here I wrote y as f of x to make it a little bit easier. But a lot of time we actually don't put f of x, we keep it a y. Now finally I need dy dx. Finally I need dy dx. So I solve for dy dx. So now solve for dy dx. I get dy dx equal 1 over 2y. So the dy dx is going to be 1 over 2y. So now suppose I zoom in. I tell you find. I'm still working with the same function. So this is y squared equal to. So let's see part A, find dy dx. And part B is find dy dx at the point. And now I have to give you
question. Shouldn't
the x value, and I have to give you the y value. Because if I don't give you the y value, we have two different points, and I'm not allowed to, I don't know which one I want. So at the point 4, let us say -2. Because if that's the graph. If I have a 4, they have two y's. So if I'm asking you, I want the y, the dy right here. So I have to give you the y value. This formula tells me, you know, whatever it is, it's 1 over 2y. My y is -2, which is the -4, which is exactly what we got before, but I didn't have to break my plan. I don't have to solve for y as a function of x. I didn't have to do it 2 times. I can do it only 1 time. And do another problems because those problems need a little bit of time, not a lot, a little bit of time to think. So I'm going to do another problem. So let me consider the following curve. Okay.
Someone's trying to ask a question. You just can't hear them very well.
Oh, I can't hear at all. Please, whoever's asking, try again.
Why isn't that 2y to the 1/2?
I still don't hear for some reason. Can anybody else hear him and tell me?
He said, why is that 2y to the 1/2? That's what he said.
Why it is 2y what? Don't worry, guys. Just keep asking. You have to understand this.
He said, why is it 2y to the 1/2? Or why isn't it 2y to the 1/2?
But I don't have 2y to the 1/2. Where? It's just 2y. There is no
I think he's
half.
asking when you take the derivative of y squared, why does it become 2y instead of like bringing down the exponent and then subtracting it by 1 pretty much.
But the exponent is squared. I don't. Yeah, I mean, it's 2. So what's the exponent here? It's 2. 2 minus 1. Are you with me? Yeah. Okay, sorry, I took a while to understand. All right, so let me take another problem, a little bit harder, but it gets the mechanic going. So let me take a curve, an equation. That's the equation. Okay, 6xy. All right, let me consider this equation. So that's the relationship between x and y. And it looks bizarre to you, I agree, totally. And graphing this equation is actually not easy at all. And decimals graph it very easily. I mean, they can do it. So if we graph, we get something like that. It means if I sketch all the points that satisfy this equation, I'm going to get this kind of a picture. And as you realize, for 1x, there are 3 different values of y at some point. So x is definitely not a function of y. And solving for y as a function of x is very hard. But before we do that, let me ask you a simple question. Is the point 1, 2 on the graph? What does it mean? Before even we hit derivative, is the point 1, 2 on the graph? What does this mean to you? It means if I plug in 1 for x and 2 for y, is this equation satisfied? Okay, if I plug in 1 here, plus, okay, 2, which is 2 to the power 3 plus 8. And the question is this 6 times 1 times 2? Definitely not. So the point is not on the graph. So finding even 1 point on the graph is hard. Can anyone give me a point on the graph? It means, can anyone give me pair x and y that satisfy this equation? That's what it means on the graph. 0, 0, absolutely. If I take 0, here, 0, that's a point on the graph, which is this point right here. That's a point. Now, is the point 3, 3 on the graph? I don't know. What do you think? Is it? Everybody, is it? Okay. If I plug in 3 for x, what would I get? 3 to the power 3 is 27. And I plug in 3 of x, 27. Is it equal 6 times 3 times 3? And that's 54, right? 3 times 3 is 9, 9 times 54. Yes. Okay. Finding 1 point is hard. I mean, this is really not easy to do it. But computer algebra system or Desmo, they actually approximate the solution. They don't really solve, they approximate it. All right. Now my question is, I want to find, so 3, 3 is going to be somewhere, I think it's going to be somewhere in here. And my question is, okay, what's the slope here? Okay, so in this problem, I cannot even, I mean, the other problem I start with an easy problem, y squared equal to x. I was able to solve for y as a function of x. Here, I cannot even solve for y. I really don't know what y is a function of x. I still need the slope. So in the back of my mind, so this is my equation, the way I think about it, and I want you to think, is that, you know, we don't know what y, we don't know how to solve for y as a function of x. But y is in a way a function of x, but this function changes depending on the point. So in this graph, I may have one rule that will give me this piece of the graph. That's what's going to happen. And there is another rule which will give me that piece of the graph. And there is a third rule which will give me that piece of the graph. So actually, for this equation, we will have three rules. One that give me the red piece, one will give me the black piece, and one this give me the swiggle piece. So there are a lot of functions that gives me y as a function of x. So y is a function of x, but it's something that's changing with x. It actually changes. So how are we going to differentiate? Keeping in the back of my mind that I say, okay, this is already something, it's a function of x, it changes, but locally it is 1. So I say, okay, those two are equal to each other. It means the derivative of the first is equal to the derivative of that. So remember, this is a function that we don't know. And now that's the hard part of the whole thing. What's the derivative of that? This is a sum, we're adding. So it's going to be the derivative of the first term plus the derivative of the second. Now, what's the derivative of x cubed? X is my variable. So this is like you're differentiating x to the power 3. That's 3x squared. There is no problem in that. Plus, y cubed is problematic because y is not a y. So the derivative is not 3y squared. Y is a function of x, which changes, but still it's a function. So it's going to be the derivative of y to the power 3. So we don't have y. We have z. My variable is x. So what's going to be the derivative of y cubed? All right, this is the chain rule. It's the derivative of the outside. So the outside now is u to the power 3. So the derivative of the outside, which is 3 times to the power 2, but evaluated at the inside function. But the chain rule tells me you have to multiply it by the derivative of the inside. So I will write y prime instead of dy dx for simplicity. So there is no, so it's 3y squared times y prime equal. Okay. Now, what's this? Derivative of 6xy. What do I see in here? So here it says sum. What do I see in here? What I see in here is 6x times y. That's a product. Okay, it's very slowly. Now, how do we handle a product? So it's equal to what? So that's the derivative of 6x times y plus 6x times, there's only one y times the derivative of y. Always remember, it's not a y. It's a function of x that I don't know what it is. That's, you have to keep this always in mind. So now we are there. Equal to, the derivative of 6x is 6. Y plus 6 y prime. Okay. The last step is to solve for y prime. Okay. To solve for y prime. How do I solve for y prime? To solve for y prime, I first need to isolate the y prime. So I need to put those together and then isolate y prime. So how do I do that? So this is 3. I'm going to rewrite it, y prime. And then minus 6x y prime. Okay, so I'm trying to isolate them. And everything that has no y prime in it will go to the other side. So 6y, that's minus 3x squared, and that. Now, I want to isolate y prime. To do that, I have to basically factor it out. And this would leave me with this. And finally, I solve for y prime, or dy dx, if you like. So it's y prime or dy dx. Now, if I want a specific point, so if I want at the point 33, so if I tell you, okay, what's the slope of the tangent line at the point 33, and realize I have to give you the x value and the y value, and now you just plug in 33 here. We get 6 times 3 minus 3 times 3 squared over 3 times 3 squared minus 6 times 3. Okay. And it seems to be -1 in this particular simple scenario. All right. So that's implicit differentiation. A little bit hard at the beginning because it's very abstract for us. But hopefully by next Wednesday, we will totally have it under control. Okay. So for Wednesday, I will assign problems about implicit differentiation. You may struggle with them, but we will spend quite a bit of Wednesday working with implicit differentiation. And then, as you know, exam 2 is next Friday. You will have the review tomorrow. Okay. Any questions? All right, please start your quiz, and the best, have fun during the break.